Yo, what's up, Nerd Herd? So, for the past few years, Intel has been playing defense in mobile computing. Apple reset expectations with Apple Silicon, AMD steadily improved efficiency and integrated graphics, and Intel, despite huge branding pushes, struggled to convince buyers that its laptop chips were actually moving forward. Now, Intel says Panther Lake, branded as Core Ultra 300, is the turning point. So, reviews are out, benchmarks are in, and on paper, the gains look real. The question is, did Intel improve? No, actually, the better question is, how much, right? Where and whether it actually changes buying decisions. Let's break that down today. Welcome to the Nerd Herd. Alright, so let's start with what's confirmed. Intel officially announced Core Ultra 300 series mobile processors, internally known as Panther Lake, at CES 2026. These chips are built around three major pillars: CPU improvements, a redesigned integrated GPU using the Arc X3 architecture, and a dedicated NPU for AI workloads. So this is not a minor refresh. Panther Lake's Intel first major mobile platform, designed from the ground up to compete in a world where efficiency, integrated graphics, and AI acceleration all matter at once. So, early reviews, including analysis summarized by video cards, which I'll provide right here or here, focuses on two main areas: the CPU performance gains and the integrated GPU gains that are much larger than previous generations. So let's talk about CPU first. Confirmed from reviews, Panther Lake CPUs show meaningful multi-core improvements over previous Core Ultra generations. Single core gains exist, but they are modest. Multi-thread workloads benefit much more. This suggests Intel focuses on core efficiency and scaling, not just peak clock speed. That aligns with Intel's architectural shift towards balancing performance cores, efficiency cores, and power management rather than chasing raw gigahertz numbers. So, why does that matter? In real terms, this all means a better sustained performance in long workloads, less throttling under continuous load, improved responsiveness when multiple tasks compete for resources. So this is important and relevant for creators, developers, and power users running sustained workloads, not just short benchmarks. So this is where Panther Lake actually changes the conversation. Let's go over some confirmed facts. Intel's new integrated GPUs, branded as Arc B series, shows a large performance gain compared to previous Intel GPUs. In some gaming benchmarks, reviewers reported 30 to 50% improvements depending on configuration and title. These gains come from more execution units, higher clocks, architectural improvements from the XE3, better memory support using fast LPDDR5X. What is not confirmed, though, is you may see claims online comparing these iGPUs to discrete GPUs like the RTX 3050. Those comparisons are not official, not consistent, and they should be treated cautiously. What's fair to say, though, is that integrated graphics are now good enough that many users will not need a low-end discrete GPU. That's a huge shift. So let me step back and ask why this generation looks different. Here's the industry reality from a big picture. Discrete GPUs are expensive. They increase laptop costs, complexity, and power draw. Margins on low-end GPUs are thin for OEMs. And at the same time, consumers increasingly expect light gaming, hardware acceleration for creative apps, long battery life, AI features that actually run locally. Intel's response is simple economic logic. If you can deliver good enough graphics and AI acceleration on die, OEMs can lower the bill of materials, simplify cooling designs, sell thinner, lighter laptops at better margins. So Panther Lake is Intel aligning its silicon with OEM initiatives, or should I say incentives, not just benchmark charts, right? But you'll see some skepticism online about Intel's power claims. The skepticism is warranted. Confirmed reality, many Panther Lake chips are designed around a 25 watt base power target, but Turbo behavior still allows much higher short-term power draw. This is not misleading, it's how modern mobile CPUs work. Battery life depends heavily on OEM tuning, cooling design, display choice, workload. Early reviews suggest sufficiency has improved, but results vary widely by system. So yes, Intel is better here, and no, battery life is not magically fixed across all laptops. For consumers, Panther Lake changes the laptop market in 3 ways. Let's go over pricing. So fewer low-end discrete GPUs means potentially lower prices or better specs at the same price. The availability now is OEMs can ship fewer SKUs and simplify product lines. So that usually means more refresh cycles, more consistent availability, and I would say choice. This is the trade-off. If integrated graphics become a good enough, right, product, some niche configurations may disappear. It's great for mainstream buyers and less great for enthusiasts who want very specific combinations. Let's go over some confirmations. Intel has made real progress. Yes, CPU efficiency is up. Integrated graphics are no longer a joke. AI acceleration is finally first class. But here's some industry reality on this. This does not suddenly dethrone Apple or AMD everywhere. It does not make discrete GPUs obsolete. It does not fix every laptop design overnight. But it does put Intel back into some serious competition in mobile computing. And for the first time in a while, that contention is based on architecture, not marketing. If you want to follow up on deep dive comparing Panther Lake directly to AMD Ryzen or the Apple M series laptops in real world scenarios, let me know. And if this breakdown helped you understand what's actually changing, consider subscribing. I try to chase the no hype and just go through the tech analysis. Well, this was Nerd Herd. I'll see you guys later. Bye.